Hey there, everybody. Today we're going to be talking about whether relationships are proportional or not. Specifically, we're going to be using tables like these and graphs like these and looking at the information on those and figuring out if that information is proportional or not. So our I can statement for today is I can identify proportional and non-proportional relationships. We're going to use tables and graphs to review the properties of proportional and non-proportional relationships. So what does proportional mean? Remember, proportional is the same as saying equivalent ratios. Equivalent goes in that blank right there. All right, so let's go ahead and take a look at some tables. It says Jet A and Jet B are both companies that rent jet skis. If X represents hours and Y represents cost, find the ratio of Y to X for Jet A and Jet B and answer the questions that follow. And then it says why is Y on top and X on the bottom? Okay, we'll answer that in just a second. First of all, let's make sure we label the number of hours. This first column here is going to be the X values. How do I know that? Well, because it says X represents hours here. And also, anytime you have a table with two columns, the X really should be on the left and the Y really should be on the right. So that's something you can depend on as well. And so Y for total cost, as it says right there, plus it's on the right. Now it says ratio Y over X. Y is the Y on top and the X on bottom. Do you guys remember a few weeks ago we were talking about like constant of proportionality and things like that, and we said the Y has to go on top and the X on bottom? Same thing for unit rate. Y was on the top and X is on the bottom. That's just our convention in math when we're talking about rates of change, ratios, things like that. Usually you're going to see Y on X and Y on X. Yeah, exactly. Y on top and X on the bottom. Okay, so let's go ahead and fill out the ratio. I want you to write these ratios kind of over here toward the left because there's more that we're going to write on the right. Okay, so number of hours, 1, total cost 75. So we're putting the Y on top, so 75 goes on top and 1 goes on bottom. For this next row, we're going to put 120 on top and 2 on the bottom. Here 165 over 3, and here 210 over 4, and here 255 over 5. Okay, now what we're looking for is whether or not all of these ratios are the same. Well, not necessarily exactly the same, but at least equivalent. It's really hard to compare them right now because the denominators are all different. So the simplest way you can compare ratios, if any of you remember this, you get a gold star, is the unit rate. Do you remember how to find the unit rate? The simplest way to find the unit rate is to take the top number and divide it by the bottom number. So I just got my calculator here. Feel free to use your calculators. We don't necessarily need it for the first one because anything divided by 1 is just going to be itself. So the unit rate here is 75. What about 120 divided by 2? Use your calculator if you want. I know that one is 60. I'm going to use my calculator for the third one though. 165 divided by 3. That's 55. Okay, so here 210 divided by 4, 52.5. And then 255 divided by 5, and that's going to be 51. Okay, so we have all of these unit rates. All of these are our unit rates. Are they all the same or are they different? They're totally different, right? Okay, we're going to come back to that in just one second. Let's go ahead and look over here at Jet B, that other jet ski renting company, and we're going to go through the same process. So we're going to make these ratios with Y over X, and again, this is X on the left and Y on the right. So first ratio is going to be 45 over 1, 90 over 2 for the second row, 135 over 3, 180 over 4, and 225 over 5. Okay, so same drill. Let's go ahead and divide those top numbers by the bottom numbers to find the unit rates. 45 divided by 1, I'm pretty sure is going to be 45. 90 divided by 2, I know that one also. That's also 45. But what about 135 divided by 3? Let's figure that up. 135 divided by 3, oh look at that, that's 45 also. What about 180 divided by 4? Got another 45. And what about 225 divided by 5? What do you guys think? Yep, it is also 45. Okay, so when you look at these two tables, As you can see, all of these numbers change. No, they don't change. All of these numbers, all of these unit rates are the same. Whereas over here, all of these are different. So that means that this table here is proportional. I'm just going to abbreviate there. Whereas this table here is not proportional. Okay, so for the tables to be proportional, all of the unit rates have to be the same. All right, so let's answer some of these questions down here. How are these tables alike? Well, they all list number of hours, total cost, and they have a column for ratio. They're both jet ski companies. They both have gray headings and then white blanks down here. Under number of hours, they both have 1, 2, 3, 4, and 5. So there's some similarities there. They both measure the total cost in dollars. So there's some similarities. How are they different? Well, the values under total cost are different, and the values under the ratio column are different as well. So there's some ways they're different. Which one is proportional? Well, we talked about that. The one where the unit rates stay the same is the one that's proportional. So I'll just go ahead and say jet B there. What makes your answer in part 3 a proportional relationship? Do you remember what we said? It's because the unit rate stays the same. You could also say the ratio, but remember that you have to get the ratio totally simplified so that you can really compare it properly. I'm just going to say the unit rate stays the same. All right. Okay, so let's look at some more tables, and then we'll go on to graphs after this. Okay, so this table is proportional. This table is not proportional. What about this table? All right, let's just take a look. So 2, 10, let's make our ratio out here to the side. Remember y over the x, so we have 10 over 2, 20 over 4, 30 over 6, 40 over 5, and 50 over 10. Now, if I go ahead and divide those out, 10 divided by 2 is 5, 20 divided by 20 divided by 4 is 5, 30 divided by 6 is 5, 40 divided by, I wrote the wrong number here, look, it's supposed to be an 8, sorry about that. 40 divided by 8 is 5, and 50 divided by 10, also 5. And if you want to look at it a different way, you can almost just say that the scale factor is that we're multiplying by 5. To go from the x to the y, 2 times 5 is 10, 4 times 5 is 20. You could think of it that way as well. And remember, every row in the table has to follow the rule. It has to be 5 for every single one, no exceptions allowed, in order for the table to be proportional. Now what about over here? It says the table is not proportional. We have 10 over 1, that's going to equal 10, right? 30 over 2, it's going to equal 15. Well, look, we already have a different unit rate just in the second row. So we already know that that table is not proportional because the whole thing has to have the same unit rate all the way down. What about this table over here? Okay, so let's look at it. Negative 8 divided by negative 2 is going to be 4. Negative 1 divided by negative 1 is going to be 1. Okay, is it proportional? It is not, because these unit rates are they're just not the same. So it is not proportional. So conclusion, to determine the proportionality from a table, the ratio of y to x must always be the same. Okay, it's got to be the same. Let's take a look at some graphs. All right. Okay, so at the top of that second page of notes, it says using graphs to determine proportionality. Okay, let's read this little problem we've got here. Razor A and Razor B. Have you guys ridden in Razors? I never have. I bet some of you have. But they're those like fun ATV vehicles, right? Okay, so Razor A and Razor B are both companies that rent ATVs. If X represents hours and Y represents cost, find the ratio of Y to X. Always Y on top, X on bottom, right? For Razor A and Razor B, and answer the questions that follow. And then they ask again, why is Y on top and X on the bottom? Same reason. When we're comparing rates of change and ratios and things like that, the Y is always going to go on top and the X is going to go on the bottom, and you're going to hear lots and lots about that in 8th grade math too. Okay, so for Razor A, we've got all these dots on the grid. That's all we have to go on. So let's just write our sort of ordered pairs for the dots, and then we'll have better information to compare. So we have an x for this dot where our x value is 0 and our y value is 30. Okay, so I've got 0, 30 for that one. What about for this dot here? It looks like our x value is a 1 right there, right? So I'll write a 1, comma. Well, we're between 60 and 90. It looks like we're counting by 15s here. 15, 30, 45, 60, 75. So our y value is going to be 75 right there. Let's go ahead to the next one. It looks like, okay, just kidding. It looks like 2, there we go, now I've got it, 2, comma, 120. And this next one is going to be 3, comma, let's see, we need 15, 150 plus 15, so that's 165. And then the next one, this is a 4, right? Okay, so 4, comma, 210. And here we have 5, comma, 240 plus 15 is 255. All right, so now I'm going to compare these just the same way as if it were in a table. Like if I had a table, I could just kind of do 0, 30, 175, 2, 120, and then write my ratios out to the side. I don't feel like I need to write the whole table because I have the information here too, but if it helps you to make the table to feel more organized, you certainly can. I'm just going to write my unit rates out here to the right of each ordered pair. So 30 divided by 0, you know what? You can't do that. You can't have 0 as the denominator, so we're just going to X that one out. And let's go to 1, comma 75. Okay, so that's 75 over 1, which equals 75. Okay, what about this one? 120 over 2 is going to equal 60. And now what about this? 165 over 3 is going to equal, I'm thinking 55. 55. And 210 over 4 is going to be, I do not know what, but we're going to find out, 52 and a half. And then 255 divided by 5. 255 divided by 5 equals 51. All right, and if these numbers are starting to look familiar here, it is because those are the same numbers that we had over here on this grid. Same values as in the table. So we're just kind of connecting. We're using the same bits of data for the tables and for the graph. So you already know the answer to this question. Is this proportional or not? You know it's a no, but we're going to talk more about why it's a no. Okay? So first of all, it's a no because they have different unit rates. But we're also going to show you kind of a shortcut way to tell with a graph whether it's a yes or no without having to divide all these numbers out. All right, let's go ahead and look at these. 0, 0, we're not going to have one for that because with the 0 on the bottom, you can't do the math on that. So it looks like we have 45, comma 1. I wrote that backwards, my bad. 1, comma 45. There we go. And now 2, comma 90. 3, comma 135. 4, comma 180 for that one. And then 5, comma 210 plus 15, 225. Okay, now we already know what happens when we divide all these out because we did it here. All of these are going to equal 45. So 90 divided by 2 is 45. 135 divided by 3 is 45. 180 divided by 4 is 45. And 225 divided by 5 is also 45. So they are all 45. So you know, because you know how to read it from a table, you know that this is proportional. But still, we haven't talked about our trick. We're getting to it. I promise we're getting to it. Now let's just connect the dots. Let's see the shape that these dots make. You may have already noticed that they both make a straight line. All right, let's keep going. How are the graphs alike? Well, they both make a line. They both go up. Both go like upwards. Let's see, what else do they have? They both have hours versus cost. Hours versus cost. And you might see some other similarities. Feel free to write down whatever you see there. Now, how are they different? Well, there are different values, especially the y values are different, right? 1, 2, 3, 4, 5 stays the same, but the y values are different. So I'm going to say different y values. And what about this one? It looks like this one starts at 0, 0, and this one does not. One starts at 0, 0, and the other doesn't. So that might be important. Okay, let's go ahead and answer 3. Which one is proportional? All right, I think we already know that razor B is proportional because all these unit rates are the same. So razor B. And what makes it a proportional relationship? And I'm going to say same unit rate. All those 45s over there, right? We still haven't covered the trick yet. I'm getting to it, I promise. We're getting to it. Okay, so let's look down here. It says this graph is proportional. This graph is not proportional. What about this graph? Well, don't worry about him just yet. But this graph, you see this line? It's exactly like this line, right? Except just like moved down on the graph a little bit. So what's the deal? What makes this one proportional and that one not proportional? Well, look for similarities and differences. They're very, very similar, but the main difference is this one goes through 0, 0. Right here, that point, that's where the y-axis and the x-axis meet. That's also called the origin. This one goes through the origin. This one does not go through the origin. Well, let's look back up here. Let's see, this one is proportional. Does it go through the origin? Does it go through 0, 0? Yeah, it does. What about this one that's not proportional? Does it go through 0, 0? No, it doesn't. So it looks like we kind of have a pattern here, don't we? So let's make our rules. To determine proportionality from a graph, down here in the conclusion section, right? To determine proportionality from a graph, the points must form a line, and they also must go through 0. I'm going to say 0, 0, or the origin. They're the same thing, just two different names for the same thing. Okay, so now that we know our rule, let's talk about this graph right here. Well, does it go through 0, 0? Yeah, it sure does. There's 0, 0 right there. But is it a line? No, this is very curvy, so this one is not proportional. It really does have to be a line in order to be proportional. So you need those two things. It has to be a line, number one, and it has to go through the origin, or 0, 0 is the second rule. All right, so that is your notes for today. Let's look at your assignment super quick. So it's 2 pages. It looks so long, but it's really not. Things are just spaced out. You're going to look at number 1 and figure out which of the tables are proportional. So use your unit rates here, okay? And now here, you're going to use that rule about being a line and going through 0 to figure out which of these are proportional. In number 3, you have a little bit of a word problem. So you have how many sweaters Fiona sold on different days, or different hours, I believe. So you might want to just make yourself a table of data. You could put the hours on one side and the sweaters on the other side, make yourself some ratios, figure out if that unit rate stays the same or if it gets different. Okay, so that's the number 3. And then on numbers 4 and 5, you get to be a little bit creative. You're going to make a table that is proportional and then make one that's not. And then you're going to have to explain how you can tell, that says it, if you can tell from a table if there is a, okay, I just read it wrong, my bad. So you're just going to have to explain how you can tell from a table whether it's proportional or not. Similarly, you're going to make a graph that is proportional and a graph that is not proportional. And then you're going to explain how you can tell. And then you guys can skip number 6. All right, if you have any questions, let me know. I'd love to hear from you. And I'll talk to you later. Bye.